All right, so now that we know that electrons are charged, how is it that we know how much charge an electron has? Well, in 1909, an enterprising scientist by the name of Robert Millikan decided to answer that question, or at least to try to answer that question. And the result is one of science's most famous, most ingenious experiments, known as the Millikan oil drop experiment. So as we watch this experiment and I describe it, we're going to have a backdrop of another song dealing with electricity that you probably know.
The bottom of the chamber consisted of electrically charged plates. He introduced a source of X-rays which can cause creation of charges when they strike matter. Charges produced by the X-rays attach to an oil droplet, producing one or more charges on the droplet. When there is no voltage applied, the fall of the droplets is determined by their mass and the viscosity of air through which they fall. When a voltage is applied, the droplets that have a negative charge will fall more slowly, stop falling, or even rise, depending on the number of charges on them. By adjusting the applied
And once the drops were suspended in air between the two metal plates, Millikan was then able to measure the charge on the drops because he knew the mass of the drops, which was pulling down on the object, and he knew the electric force on the charge, which was pulling up on the charge, and the fact that those forces had to be equal. He could calculate how much charge was on an electron. Now, what did he discover? What he discovered is that the charge on the electron is negative 1.6 times 10 to the negative 19, right? So you can think of a way to remember this number is you turn 16, yoo-hoo, happy birthday, and then the last year that you're a teenager is your 19th year. So 16 and 19, 1.6 times 10 to the 19th, happy birthday to you, happy birthday to you. Okay, so that hopefully will help it stick in your head. That's the charge of an electron, a very important number to know, something that you should put on your equation sheet. A proton, the exact same amount of charge, but it's a positive number. Now, what is a Coulomb? A Coulomb is an amount. In fact, 1 Coulomb of electrons is 6.25 times 10 to the 18th, which is 6.25 billion electrons. It's a lot of electrons. But we're just concerned with this number, which is the amount of charge on an electron. Now let's say I have two charges, a negative and a positive. We know that they exert a force on each other, but what is that force? How can we find it? Well, luckily, the topic of today's video is the exact way to do that. It's called Coulomb's law. Coulomb's law should look very familiar to us. it looks very similar to our equation for gravity, which was Fg equals G m1 m2 over r squared. So in Coulomb's law, the electric force between two charged particles is equal to a constant called the Coulomb constant, which has a value of 8.98 times 10 to the 9. This Coulomb constant, we're going to make 9 times 10 to the 9th for our equation. And then it has Q. Now, Q is the amount of charge on here measured in coulombs. Q2 is the amount of charge on the other object, or the other charged object, also measured in coulombs. And by the way, a coulomb, the abbreviation is the letter C. And then the distance of r squared. So electric force equals K, Coulomb's constant, Q1, Q2 over r squared. That's the equation. A way to remember it. A way to remember this equation is ferret. Knits, queens, quilt. Right? So ferret, knits, queens, quilt. Okay, right? So ferret, knits, queens, quilt, right? So that's one way to kind of remember the equation. Now, let's put it to practice. So here's our question. So take a second and read it here. It says the electron and proton of a hydrogen atom are separated on average by a distance of 5.3 times 10 to the negative 11th meters. In our equation for force electric, R should be in meters, which it is. It says find the magnitude of the electric force and the gravitational force that each particle exert on each other. So the two equations we need are the two related equations, F electric and force gravity. So let's start with our force electric. We want to find the force electric. So what are our knowns? Okay, here are our knowns. So I'm going to take them now and plug them in to our equation. Remember, K is also a known. So our setup looks like this when we plug it into the equation. Notice that Q1 and Q2 are opposite signs. The electron has a negative charge, the proton has a positive charge, but it's both this number. Happy 16th birthday. You're a teenager till you're 19, right? So 1.6 times 10 to the negative 19. And now we can solve and get our answer. Okay, when we do the math here, we get a force electric of negative 8.2 times 10 to the negative 8th newtons. One thing to note here, this negative sign tells us something. If Fe, the force, is a negative force, it's an attractive force, which is what we expect. Having an electron and a proton, their opposite charge, they're going to attract. And then Fe is positive, it's a repulsive force. Okay, so there's negative, nothing to be scared of. Now, what about the second part? What do we know to find the force of gravity? Well, we need to know the mass of the electron and the mass of the proton. So here are our knowns for this problem. Let's plug it into the equation and find out the force of gravity. We put it in the equation like this. I will say, when you're doing a problem in this unit, keep 3 digits on these masses. So I didn't do that in my known column, but 9.11, for example, times 10 to the negative 31, 1.67 times 10 to the negative 27th kilograms. And the reason is because these are really small numbers. So let's have because changing it a little bit can make a big difference. So let's keep 3 digits when we do that. We solve this and we get force of gravity. And we get a force of gravity of 3.6 times 10 to the negative 47th Newton. That's super, super small. That's so small that it's almost negligible. In fact, when you compare the electric force, it's 10 to the negative 8. That's almost 10 to the 40 power time more strong than the force of gravity. And that has some implications that we'll talk about in class. But just know the electric force much, much bigger than the gravitational force when the particles are close together. A question here using Coulomb's law. Here's a question from page 566 in the book. Go ahead and read the question there. And then let's write out the equation. So ferrets knit, queens, quilts, right? Okay, so we've got this, and now let's plug in our knowns. Here I have my knowns. I'm going to put them in the equation, and we're solving for r squared, right? So we're actually solving for r, the distance. Changing the equation a little bit, we end up with this to find r. So now we can plug everything in. And so what we have here is r, plugging everything in, r ends up equaling 0.393 meters. So that's our final answer. So that is Coulomb's law. Hope you had a positive experience with that. And if you did have a negative one, we'll talk tomorrow, and I won't charge you a thing. Have fun.